Welcome to our tutorial on building a random forest classifier in Java. Today, we will dive deep into what random forest is, how it works, and how to implement it in Java from scratch. First, let's understand the concept of random forest. A random forest is an ensemble learning method used for classification and regression. It builds multiple decision trees during training and outputs the mode class for classification or mean prediction for regression. Now, let's look at the key components of a random forest. 1. Bootstrap sampling. Random forest uses bootstrap sampling to create subsets of the original dataset. Each tree in the forest is trained on a different subset. 2. Feature randomness. When splitting nodes during the training, random forest selects a random subset of features to decide the best split. This randomness helps in ensuring diversity among trees. 3. Voting/averaging. For classification, each tree votes for a class. The class with the majority votes becomes the final prediction. For regression, it averages the predictions from all trees. Let's set up our Java project. We will be using Java along with the popular libraries like Apache Commons Math and Weka to streamline the implementation. Next, ensure you have installed the Apache Commons Math library. You can download it from their official website or include it in your project using Maven if you're using a build management tool. Now let's write the code for our random forest classifier. We will start with the main class that kicks off our entire program. Inside the main method, we'll proceed to load our dataset. For the sake of simplicity, let us consider a simple CSV file containing our features and classes. The DataPoint class stores a single instance of data with features and the corresponding label. Let's define that next. Now that we have defined our data structure and loading function, let's build a method to create our random forest. This method will create a number of decision trees based on our bootstrap samples. In the build forest method, we will also need to implement the bootstrap sample method, which creates a resampled dataset from our original dataset. Now, let's implement our decision tree class, which is fundamental for our random forest approach. This class will handle the creation of a single decision tree. Within the decision tree class, we need to implement the decision-making logic that decides how to split the dataset at each node. This involves calculating the best feature to split on. We also need a way to make predictions with our random forest. We will create a method that aggregates predictions from all decision trees and selects the majority vote. Now we have the basic structure for our random forest and decision trees. Next, we will test our model with some sample data. You can create a CSV file with sample data for this. Once our forest is built, let's see how it performs on a test dataset. We will load the test data and make predictions. Before we conclude, let's look at how we can evaluate the performance of our model by calculating accuracy based on the predictions we made. Congratulations! You have successfully built a random forest classifier from scratch in Java. You can further enhance functionality by implementing hyperparameter tuning methods, plotting feature importances, or working with more advanced data pre-processing techniques. If you enjoyed this tutorial and learned something new, don't forget to like, share, and subscribe for more content. If you have any questions, feel free to leave a comment below.